Kawasaki Maintenance Mastery, Part 2, Chassis, Braking, and Electronic Systems. Continuing our journey into the mechanical soul of Team Green, we shift our focus from the internal combustion process to the components that keep that power under control. A Kawasaki is more than just a powerful engine. It is a complex interaction of geometry, friction, and electronic logic. When these elements fall out of alignment, the riding experience degrades from exhilarating to dangerous. In this second part, we explore the critical errors in chassis management and the braking systems that define the performance of models like the Ninja, the Z-Series, and the Versys. Precision braking. Beyond the surface, the braking system on a Kawasaki is designed for high-performance stopping power, but many riders fall into the trap of neglectful maintenance. A common error is ignoring the health of the brake fluid. Kawasaki uses high-performance systems that generate significant heat, especially during aggressive downshifting or track sessions. Over time, brake fluid absorbs moisture, which lowers its boiling point. The error here is waiting for the fluid to turn dark before changing it. By the time you see a color change, the internal seals and the ABS pump may already be compromised by internal corrosion. The solution is a full system flush every 2 years using a high-quality DOT4 or DOT 5.1 fluid, depending on your specific model's requirements. However, the real secret to Kawasaki braking performance lies in the caliper pistons. These pistons are exposed to road grime and brake dust. If they are not cleaned regularly, they can drag, causing excessive heat buildup and warped rotors. When you change your pads, don't just push the pistons back in. Clean them with a soft brush and brake cleaner first. This ensures that the retraction is smooth and that your lever feel remains firm and consistent, giving you the confidence to trail brake into any corner. Suspension and chassis alignment suspension is often the most neglected part of motorcycle maintenance. A frequent error among Kawasaki owners is riding with factory settings that were never adjusted for their specific weight or riding style. A bike that is too soft will wallow in corners, while one that is too stiff will lose traction on uneven pavement. Furthermore, many riders ignore the fork oil. Just like engine oil, fork oil shears down and loses its damping properties. If your front end feels divey, under braking, or harsh over small bumps, your oil is likely spent. The solution starts with setting your static and rider sag. This ensures the bike sits in the correct part of its travel. For the front forks, especially on high-mileage Ninjas or older Z models, a full service including new seals and fresh oil of the correct viscosity can make the bike feel brand new. Additionally, pay close attention to the steering head bearings. Kawasaki's often come from the factory with a minimal amount of grease in this area. If you feel a notch in the center of your steering, your bearings are notched and must be replaced. Proper lubrication and torque of these bearings are essential for that razor-sharp handling Kawasaki is famous for. The final drive, chain and sprocket errors the power of a Kawasaki is delivered to the ground through the final drive, and this is where many avoidable errors occur. The most common mistake is over-tightening the chain. A chain that is too tight puts immense pressure on the countershaft bearing and the rear wheel bearings. When the suspension compresses, the chain pulls even tighter, which can lead to a snapped chain or, worse, a cracked engine case. Conversely, a loose chain will slap against the swing arm and cause jerky throttle transitions. Per TEA gratis, per mi fa la differenza, iscriviti al canale. The solution is to always measure chain slack at the tightest point while the bike on its side stand, following the specific measurements located on the swing arm sticker. Don't just look at the chain. Inspect the sprockets for hooking or chipped teeth. A worn sprocket will destroy a new chain in a matter of hundreds of miles. Clean your chain with a dedicated cleaner that won't damage the O-rings and lubricate it while it is warm after a ride. This allows the lubricant to penetrate the rollers more effectively, ensuring a silent and efficient transfer of power. Advanced electronics and KTRC logic modern Kawasaki's are packed with electronic rider aids like KTRC traction control and KIBS intelligent braking. An error that is becoming more common is the failure to calibrate these systems after changing tire brands or sizes. These systems rely on wheel speed sensors to calculate slip. If the circumference of your new tire is slightly different from the original, the computer may intervene too early or too late, leading to a loss of performance or a safety risk. The solution is to perform a sensor check and, if your model allows, a system recalibration through the dashboard menu. Always keep the ABS tone rings clean. A small piece of debris or a bent tooth on the tone ring can send incorrect data to the ECU, causing the ABS light to flash and the system to disable itself. Electronics are only as good as the data they receive. By ensuring your sensors are clean and your tires are correctly inflated, you allow the Kawasaki's brain to work exactly as the engineers intended. The final pro tips, the master's checklist to wrap up this series. Let's look at the final pro tips that elevate your maintenance game. First, always use a torque wrench. Kawasaki aluminum castings are lightweight but can be fragile. Over-torquing a bolt can lead to expensive repairs. Second, pay attention to your fuel pump. If you hear a high-pitched whine from the tank, your fuel filter is likely clogging. Cleaning or replacing this filter early can prevent a fuel pump failure on the road. Finally, keep a detailed logbook of every adjustment and service. Knowing exactly when you last greased the suspension linkage or checked the valve clearances allows you to stay ahead of the wear curve. A well-maintained Kawasaki is not just a machine, it is a legacy of engineering excellence. Treat it with the respect it deserves, and it will reward you with thousands of miles of pure, unadulterated speed. Dashboard, FI codes, and system resets. Continuing our technical deep dive into the digital brain of your Kawasaki, we now move beyond simple dashboard warnings to the core of the machine, the electronic control unit, or ECU. While Part 1 focused on what you see on the screen, Part 2 explores what happens behind the scenes. When a Kawasaki doesn't feel right, perhaps the throttle response is sluggish, or the fuel consumption has suddenly spiked. The issue often lies in stored long-term fuel trims or sensor errors that haven't yet triggered a full FI light. Understanding how to manage these deeper system layers is what defines a true technical expert. ECU adaptive memory and the soft reset. The ECU in a modern Kawasaki is adaptive. It learns your riding style, the environmental conditions, and the specific fuel quality you use, adjusting the air-fuel mapping in real time. However, a common error occurs when you install aftermarket parts, like a slip-on exhaust or a high-flow air filter, without resetting this adaptive memory. The bike continues to use old data for new hardware, leading to flat spots in the power band or excessive popping on deceleration. The solution is an ECU reset, often referred to as a TPS initialization. For most Kawasaki models, this can be achieved without a computer, by following a specific sequence: turning the ignition on without starting the engine, slowly rotating the throttle to its stop and back several times, and then letting the bike idle for exactly 15 minutes from a cold start. You allow the ECU to relearn its base parameters. This idle relearn procedure forces the computer to recalibrate the oxygen sensors and the idle air control valve, effectively wiping out the old adaptive data and optimizing the bike for its current configuration. Oxygen sensor errors and closed loop glitches. The oxygen sensor is a vital component located in your exhaust header that monitors combustion efficiency. A frequent error is the code 33 or similar O2 sensor malfunctions. Many riders assume the sensor is dead and replace it immediately, which is an expensive mistake. Often, the sensor is simply lazy due to carbon buildup or contaminated by leaded fuel or silicone-based sealants used during maintenance. Per te gradus, per mi fa la differenza, iscriviti al canale. The solution involves testing the heater circuit of the sensor before discarding it. A simple resistance check with a multimeter can tell you if the internal heating element is intact. If the sensor is just dirty, a high-speed run on the highway, often called an Italian tune-up, can sometimes generate enough heat to burn off the carbon deposits and restore sensor functionality. Furthermore, ensure that the wiring harness isn't melting against the hot exhaust pipe, a common routing error after a full system installation. If the sensor must be replaced, always use an OEM spec sensor. Universal sensors often have different resistance values that will keep the FI light illuminated forever. The Limp Mode reset procedure if your Kawasaki suddenly loses power and won't rev past 4,000 or 5,000 revolutions per minute. You have entered Limp Home Mode. This is a protective state the ECU enters when it detects a critical error, such as a faulty gear position sensor or a major misfire. The biggest error riders make here is trying to ride through it. This mode is designed to protect the engine from catastrophic damage. To reset Limp Mode, you first need to identify and fix the triggering fault using the diagnostic codes discussed in Part 1. Once the mechanical issue is resolved, the error code usually becomes historical rather than active. On many Kawasaki's, a historical code will only clear after 3 clean heat cycles. A heat cycle involves starting the bike from cold, riding it until it reaches full operating temperature, and then letting it cool down completely. If the ECU sees that the error does not return during these 3 cycles, it will automatically exit Limp Mode and turn off the warning light. It is a test of patience, but it is how the Kawasaki system ensures the repair was successful. The secret Dealer Mode 2 and advanced diagnostics for the newest generations of the Ninja ZX, 10R, and the ZH2, Kawasaki has introduced deeper diagnostic layers. There is a secret sequence that many owners don't know about. By holding the select and reset buttons while turning the ignition to the on position, you can often access a secondary menu that displays real-time sensor data, such as exact intake air temperature, battery voltage down to the millivolt, and even the live voltage of the throttle position sensors. This menu is incredibly powerful for troubleshooting intermittent electrical issues. For example, if your bike stalls only when hot, you can monitor the coolant temperature and the fuel pump voltage simultaneously to see which one drops first. The error to avoid here is changing settings within these menus without knowing the factory defaults. Always take a photo of your original settings before making any adjustments. This secret access allows you to diagnose the bike while it's running, providing a level of insight that previously required a $500 diagnostic tool. Conclusion: staying ahead of the machine, mastering your Kawasaki's electronics, is about moving from fear to understanding. These systems are designed to help you, not hinder you. By knowing how to read codes, reset service icons, and perform ECU relearns, you take full control of your motorcycle's performance and longevity. You no longer have to fear the FI light. Instead, you see it as a communication from a machine that is built to perform at the highest level. Maintain your sensors, keep your connections clean, and never ignore the data your dashboard is giving you. With these tools and techniques, your Kawasaki will stay as sharp and responsive as the day it left the factory. Keep learning, keep riding, and keep that green machine perfectly synced.